Many engineers are skilled but need more industry-specific knowledge. This webinar series fill that gap by teaching key standard and best practices. We are truly excited about the opportunity and deeply grateful PIQS management for trusting Cost Umbrella top to plan and conduct this series. Let's move forward and explore what's in store for you today. Today marks the third series, design development through project lifecycle from our webinar series of 12 planned for the year 2025. On behalf of Cost Umbrella and PIQS, we are honored to welcome our guest speaker, Mr. Mohammad Tanveer Akhtar, for taking the time out for today's session. Thank you all for joining us today. Let's dive into the session. Well, before we begin today's session, let's quickly revisit what we covered in our last two webinars. In our first webinar, we explored the Project Management Office, PMO, in enhancing efficiency, maintaining control, and streamline project process. Next, we have done RIBA Plan of Works, a widely recognized framework for project delivery in the construction and design sectors. This provides valuable insights to structure project planning and executions. In our second webinar, we focused on feasibility studies and their methodology, followed by a viability assessment using key financial indicators such as ROI, IRR, NPV, and payback period. We conclude with a practical case study of a 4-star hotel to demonstrate a real world application of the financial tools. And about our today webinar, design development is divided into two main stages. First, we have pre-construction, and second, we have during construction. The pre-construction stage includes the master plan, concept designs, and detailed design, each progressively increasing the design's clarity, technical details, and coordination across disciplines. These stages align with global framework like RIBA and PMI to ensure structured progress and design maturity. In during construction, the focus shifts to executions drawing such as issued for tender, IFT, and issued for construction, IFC, along with shop drawings and as-built drawings. Other key components include BIM management, value engineering, regulatory approvals, and the stage gate reviews process, which evaluate readiness before moving to the next project plans. Next slide, please. Okay. In this slide, you can see our webinar list. We have covered on 8th of February, our first webinar, Introduction of PMO and RIBA Stages. Our second webinar was on feasibility studies and viability assessment, which we have covered on 25th of February. Today, we are doing design development through project lifecycle. Our next webinar will be on bidding, techno-commercial. Then we have value management and value engineering, cost planning and budgeting. Then we have procurement and contracts. After that, we have fundamentals of schedules and basic of EOT. Next, we have EVM and progress monitoring. Then we have cost controlling and reporting, risk management auditing. Last, we have quality management. Well, in this section, provide detail about continuing professional development CPDs program offered in collaboration with PIQS. These programs are designed to enhance your skill and knowledge, helping you stay ahead in the construction industry. We are currently offering 3 CPDs, 2 in Saudi Arabia and 1 in Pakistan. In Saudi Arabia, we have bid preparation, where you will learn the skill to develop competitive and winning bids. In cost planning, you will learn to create accurate cost plans aligned with the industry standards. And in Pakistan, we have a career in quantity surveying, where you will explore the scope, opportunities, and best practices in quantity surveying. Most importantly, we are planning to launch 2 comprehensive paid courses for industry experts. About the course details and schedules for our paid courses will be announced soon. Our goal is to equip professionals with the skill to create high quality bids and cost plans independently. These initiatives reinforce our commitment to practical industry-driven training. So stay tuned for the update. Well, before I introduce you to the guest speaker, please note that in our last 10 minutes, it will be the question and answer session. Please keep sending your question in the chat box, which will be entertained in the end. If the questions remain unanswered due to the lack of time, you are welcome to email us your queries at info@costumbrella.com. So we are honored to welcome our guest, Mr. Mohammad Tanveer Akhtar, a highly accomplished professional with over 19 years of experience in project management and reporting, a chartered member of CIOB. He has successfully led large-scale infrastructure, healthcare, power, and mixed-use projects across the Middle East. His expertise includes EPMO, reporting dynamic dashboards, risk and cost control, and cross-functional team coordination. We are privileged to have him share his practical insights and the leadership experience with us today. Over to you, sir.
Thank you, Mr. Akib. I hope you can see screen and you can listen me well. Good evening and good morning, esteemed participants, and a warm welcome to today's webinar on Project Lifecycle. I'm Mohammad Tanveer, Vice President of the PIQS Riyadh KSA chapter. And on behalf of PIQS and Cost Umbrella, it is an honor to lead you through the pivotal stage of a project journey from inception to completion. We will focus on three core topics. Firstly, the different standards of project lifecycle, examining how diverse frameworks shape project management. Secondly, design development in the pre-construction stage, highlighting the critical role of planning and conceptualization. And lastly, design development during construction, delving into how design adopt a project progress. Let's begin with project lifecycle, different standard. We will try to cover RIBA, PMI, AACE, and front-end loading method. The RIBA plan of work is a framework by the Royal Institute of British Architects to manage building projects from briefing to operation. The 2020 version, which is the latest, include 8 stages starting from 0 to 7, each with specific purpose and deliverable. The stage 0 is a strategic definition where we assess project feasibility and define the client's business case. The stage 1 is preparation and briefing, develop the project brief and assemble the team. The stage 2 is a concept design where we create initial design concepts. And stage 3, which is a special coordination, here we refine and coordinate design elements. The stage 4 in RIBA is a technical design where we finalize detailed design for construction. Stage 5 is a manufacturing and construction where we build the project and oversee progress. The stage 6, which is the second last one, is the handover where we complete and hand over the building to the client. The last stage, which is stage 7, here we monitor building performance and support operations. So key feature of RIBA plan of work 2020 is here, the RIBA gave us outcome driven with a focus on client goals, emphasize sustainability and digital tools like BIM. So RIBA is flexible for various project type and procurement method. The second method which we are going to see is a PMI, according to PMI. The PMI workflow uses a waterfall approach. It follows a linear sequential process where each phase is completed before the next begins. The first phase here is feasibility, where we assess project viability through studies, stakeholder analysis, and business case development. The second stage is design, where we create a detailed project plan, including scope, specification, schedule, and risk management. The third stage in PMI is a build, where we execute the plan to create deliverables, coordinating tasks and resources. The fourth one is test, where we validate deliverables through quality checks and testing. The second last stage, which is deploy, here we roll out deliverables to user with training and documentation. The last stage of PMI is close, where we finalize documentation, review project, release resources, and obtain sign-off. The PMI workflow with its waterfall and stage gate structure offer a clear control framework for managing project from start to finish, ideal for well-defined project with minimal changes. The third technique is in accordance with AACE, which is AACE is the Association for Advancement of Cost Engineering. AACE is one of the framework being aligned in context of design development and pre-construction stage. The AACE International Project Lifecycle is cyclic process with 4 key phases. The first phase is ideation, where we generate project idea and assess feasibility. The second phase is planning, where we define project scope, objectives, and create detailed plans. The third stage is execution, where we implement the project plan and manage resources. The last stage, as per AACE, is closure, where we finalize the project, deliver outcomes, and document lesson learned. In AACE, the cyclic emphasize continuous improvement and incorporating learning from past projects into future handovers. The cyclic nature of diagram suggests that the project management process is iterative, with each phase building upon the previous one and providing feedback for future projects. This approach emphasizes continuous improvement and learning from past experience to enhance project outcome. Now is the fourth technique, which is FEL, front and loading project management technique. In FEL emphasizes early planning through conceptualization, feasibility, detailed design phases, reducing risk, and setting a strong foundation for execution phase, where the project is brought to life. By investing more effort upfront, we can mitigate risk, improve accuracy of estimate, and ultimately deliver more successful projects. This technique consists of four major stages. The first stage is FEL1, which is conceptualization. In this stage, it's also known as pre-feasibility stage also. So the question we are looking to answer is the project worth it? We define the project's objective, do some initial study to get the lay of the land, and importantly, identify the major risk. The result is a go or no-go recommendation. Moving on, let's see the second phase, which is FEL2, which is feasibility or preliminary engineering. Here we are confirming that the project can be done both technically and financially. This is the stage where we develop preliminary design, refine cost estimate, and conduct in-depth risk assessment. The third stage is FEL3, front-end engineering design, known as FEED as well. In this final phase, we finalize a plan for execution. This involves creating detailed design, finalizing the budget and schedule, and obtaining the necessary regulatory approvals and permits. The final estimates are produced as well as design packages and the project execution plan. The last stage as per FEL is the execution phase. In this stage, we build or manufacture the project as per the finalized design, including construction, task management, resources allocation, and monitoring progress to deliver completed project output and services. Aramco implement FEL in 3 phases. Basically, this phase, FEL technique is for power plant, oil and gas sector. It's most famous. So Aramco in Saudi Arabia, they implement FEL in 3 phases. The FEL1, business case development, FEL2, feasibility study and concept selection, and FEL3, detailed scope definition. These stages aligning project objective with business goal for oil and gas projects. Aramco integrate FEL with its internal framework, including Saudi Aramco Engineering Standard, SAES, and Project Management Manual, ensuring deliverable meets safety, quality, and sustainability requirements. FEL has pivotal in projects like Jazan Refinery and Terminal and Sadara Chemical Complex, aiding stakeholder alignment, technology selection, and funding through clear project roadmap. Okay, let's move on to phase 2 of the project lifecycle, which is the design development pre-construction stage. As you can see on the slide, this is where we move from initial concept to well-defined and actionable plan. This phase is critical, focused on developing detailed design, creating comprehensive documentation, and laying the groundwork for successful construction. We will be breaking this down into 4 key stages shown on the right side of the slide. And these stages are master plan, concept design, schematic design, detailed design. Each of these will be covered in more detail on the following slides. Okay, the first stage in this phase is the master plan. The master plan is the first tangible design deliverable after the design brief and feasibility study. It provides a strategic spatial framework for entire project and defines how different functions, buildings, and circulation networks are distributed across the site. It includes key elements like zoning of land use, access road, infrastructure zone, green areas, and connectivity with surrounding developments. This early stage plan ensures that the proposed project layout is feasible from functional, regulatory, and environmental perspective. The master plan plays a critical role in initial authority discussion, especially in projects that require zoning or civil defense approval. It also serves as the foundation of cost estimation, infrastructure planning, and overall design development. In terms of formal project stages, the master plan falls under RIBA stage 1, which is concept design. It sets the direction for schematic and detailed design phases that follows. The second stage in this phase is concept design. At this stage, architects present early plans, sections, elevations, and simple 3D massing models. These illustrate key design ideas such as layout efficiency, natural lighting access, and building volumes. MEP and structure input also begin, often in coordination with architecture intent. The goal of this phase is not to finalize technical detail, but to ensure the concept is viable, functional, and visually aligned with the client's goal. Key stakeholders, including the client, authority, and planning consultant, give input before moving forward. This stage is part of RIBA stage 2 and correspond with the planning process group in PMI framework. Design maturity at this level is 10 to 20%. Let's move to the next stage, which is a schematic design. In the schematic design stage, we move from rough design idea into measurable and coordinated plans. This is where architectural layout are refined and the major building system, structural, mechanical, electrical, and plumbings are introduced for the first time in an integrated manner. During this phase, designer also consider functional efficiency, space usage, vertical circulation, and equipment zoning. The purpose is to resolve special relationship and begin technical alignment across discipline while maintaining the original design intent. The schematic design fall under RIBA stage 3, special coordination. It acts as a transition point where the design becomes detailed enough to be analyzed for constructability and cost. At this stage, value engineering potential ideas are located and implemented at detailed design stage. Design maturity level at this stage is 20 to 70%. At this stage, realistic budget is prepared and project funds are secured. Let me explain schematic design and value engineering connection. Schematic design and value engineering are closely linked in early project stages, aligning with client goals, budget, and functionality. Let me brief overview of their connection also. Schematic design with its flexible framework is ideal for introducing value engineering, allowing cost-effective changes. Value engineering review often follow these stages to assess concept. Preliminary cost estimate from schematic design are analyzed by value engineering to cut cost. For example, material substitution while maintaining design intent. SD also define user spaces. Value engineering ensure efficiency, suggesting cost-effective alternatives for design element like facade. Schematic design spots design challenges. Value engineering mitigate financial risk by preventing budget overrun early. Value engineering outcome lead to revision in schematic design, updating plans to stay within budget. Let me give you one example. regarding value engineering and schematic design. Let someone propose a glass curtain wall and open plan spaces, but cost exceed budget. Value engineering team, they may suggest combining glass with cheaper composition cladding and optimizing layout for natural ventilation to lower HVAC cost. The result will be revised design, integrate value engineering idea, reducing cost while preserving vision and gain clients approval. The next and last stage in this phase is a detailed design. The detailed design stage is where the project reaches full technical maturity. Here, the coordinated design from the schematic phase is developed into complete construction ready document. Every element from floor finish and wall assemble to HVAC duct routes and electrical paneling is clearly defined in this stage. This includes material specification, component detail, and system capacities. Cross-disciplinary coordination is vital here, as design conflicts must be resolved before tendering or construction begins. This stage also prepares key input for tender package, including the outline bill of quantity, design reports, and compliance documentation. It ensures the design meets all applicable codes, performance standards, and client expectation. Detailed design aligned with RIBA stage 4, technical design. It represents the handoff point between design team and construction team, forming the backbone of tender, procurement, and site execution. The design maturity at this level is 100%. Value engineering is completely implemented at this stage. Okay, let's move into the phase 3 of the project lifecycle, which is design development during construction. This phase is where design development continue and adopt as construction progress. This is a crucial and dynamic phase, ensuring that what was imagined and designed on paper translate successfully onto the construction site. During this stage, we don't just stop at finalizing construction drawing. Instead, the design evolved to accommodation real-world site condition, procurement realities, and ongoing stakeholder feedback. This ongoing design effort ensures that we can address emerging challenges and make improvement in real time without losing sight of project goal around cost, time, and quantity. We will explore each of these topics in detail over the next series of slides to give you clear understanding of how they fit into the construction phase and how effective management of these areas contribute to successful project delivery. So let's get started by diving into first item, which is issue for tender. The IFT, which is issue for tender, is a comprehensive design package released only to pre-qualified contractors during the tendering process. It provides sufficient detail for contractors to accurately price the work involved, but it's not necessarily a full finalized construction-ready document at this stage. The primary purpose of IFT is to invite competitive bids specifically from pre-qualified contractors, establishing a clear baseline for consistent pricing and evaluation. By providing uniform and coordinated information to all bidders, the IFT ensures that they are well equipped to prepare their tenders. A typical IFT package includes final design drawing and documentation, material and technical specification, tender instruction and bidding forms, and BOQ, and a preliminary construction schedule, a draft or pro forma contract, and a list of approved manufacturer or vendors if applicable. A key characteristic of issue for tender drawings is that they may not be 100% complete or fully coordinated for direct construction. There's often some room for contractors' question, clarification, and potentially minor optimization within their tender proposals. They provide the necessary information to price the job without getting bogged down in every minute's detail that might change slightly before actual construction begins. Contractor view the design from constructability perspective and highlight the challenges during bidding stage, and this can lead to design improvement. The next stage in this phase is IFC package, IFC drawing, which is issue for construction. These are the final approved documents used by contractors to build the project. They are the output of multiple iteration incorporating any last minute changes from the tender process, authority requirements, and value engineering outcomes. Once these documents are issued, they form the official design baseline for construction. Any variation from the IFC set required formal procedure such as change order or revised drawings. This is why clarity and accuracy are absolutely critical. IFC drawings are usually signed off by the lead consultant, sometimes with stamp showing approval from relevant authorities. These documents also help in claims management, quality control, and construction validation. IFC aligned with RIBA stage 5, which is construction. It's the version of design that lives on site, used by engineer, supervisor, subcontractor, and even for inspector. Let's have a look on the difference between IFT and IFC. Basically, okay. If you see the definition wise, the IFT is the bidding purpose. This is for bidding purpose, and IFC is for document used for actual construction on site. If you see the purpose, IFT enable contractor to understand the project scope and submit accurate bids, whereas IFC guide execution with the most accurate, approved, and buildable design. The design completion at IFT stage is 90 to 95%, whereas in IFC it's 100%. Design is 100% mature. If you see the content focus, IFT focus on pricing, scope, clarity, preliminary scheduling, and initial technical detail, whereas IFC focus on buildability, accuracy, legal accountability, and contractor guidance. The common inclusion, if you see IFT is final design, this is not for construction, but it includes specification, BOQ, tender forms, preliminary schedule, draft contracts, approved vendor list, if any. And in IFC, this package consists of final construction drawing, architecture, structure, MEP, etc., and final specification and schedules, engineering stamps, detailed construction level detail. If you see the legal status, IFT doesn't have any legal status. This is just for informational basis for pricing, whereas IFC is legally binding, governs construction scope, quality, and contractor obligation. Regarding the authority approvals, IFT may include initial or partial approval, whereas IFC is fully approved, including authority stamps and consultant sign-offs. If we refer to change management, so change management for IFT subject to change, post-tender, feedback loop from contractor may lead to design updates. But in IFC, variation required, formal changes, order, or revised drawings. Stakeholder interaction. Stakeholder interaction in IFT, it's encourage contractor feedback for constructability improvement, whereas in IFC used by engineers, subcontractor, site supervision, and inspection for execution and QC. Project phase and alignment. IFT is post RIBA stage 4, pre-tender overlap with procurement preparation, whereas IFC is RIBA stage 5, construction begins actual site execution. So use case analogy, IFT is sales brochure of the project, highlighting what's being priced, whereas IFC is construction manual, definitive instruction for building the project. I just want to explain one of this point, which is stakeholder interaction. A stakeholder interaction is crucial during the issue for tender phase, where engagement with various parties ensure clarity and fairness in the bidding process. Close collaboration with the client confirms the project scope and budget, while consultants like quantity surveyor and engineers provide detailed specification and cost estimate for a comprehensive tender package. Interaction with regulatory body, guarantee compliance with building codes and standards, and addressing contractor query through meeting or response ensure bidders fully understand the requirements. Whereas in the IFC, issue for construction phase, stakeholder interact remain essential to align all parties before building work begins. Final approval from client on plans and contract term is secured while coordinating with the contractors through pre-construction meeting, clarify logistic and details. Consultant offer technical support for any last-minute design issues and continue engagement with regulatory, ensure all permits and legal standards are met. Updating other stakeholders such as community groups on timeline and addressing their concerns, maintaining transparency and supports. Ultimately minimizing risk and ensuring a smooth transition to construction through effective communication. So this is all about IFT and IFC comparison. Now let's move to the shop drawings. The shop drawings are contractors' tool to bring the design to life. While IFC drawings show the design intent, shop drawings demonstrate how each component will actually be built, manufactured, and installed. These are typically much more detailed and often include fabrication, instruction, dimension, materials, and method. For example, a structure IFC drawing may show a steel beam layout with its length, its label, its location, but the shop drawing would include bolt hole location, weld type, and plate size for fabrication. Similarly, MEP shop drawing will reflect real-world routing of pipes and ducts based on the actual site measurements and clash-free coordination, whereas shop drawings are submitted for review by the design. Okay, the shop drawings will be submitted for review by the design consultant, not for redesign. It's not for the designing purpose, but to confirm they are aligned to design intent. Only consultant will make sure whether the shop drawings are aligned with the approved design or not. These drawings are critical for procurement, prefabrication, and sequencing the work on site. Let's now discuss the relationship between IFC and shop drawings, which is a crucial aspect during the construction phase. On the left side of the slide, you will see a simplified flow of how these documents fit into the construction process. First, we begin with the design intent, represented by IFC or issued for construction drawing. These drawings reflect the finalized design approved by consultant, capture the exact requirement and expectation of the project owner and design team. Next, we have the contractor's interpretation of the drawings. This step is about translating the design into shop drawings. Shop drawings prove detailed information customized for specific site condition. Actual material and intended fabrication are installation method. Finally, these shop drawings are submitted for consultant review and approvals. This ensures that any detailed changes or practical solution proposed by the contractor still aligned with the original design intent. The key insight here is that IFC drawings and shop drawings serve different yet complementary purpose. IFC drawings answer what need to be built, showing the end goal and design intent from designer or engineer. Shop drawing answer how it will build, adopting the intent based on the real world constraint and construction method. The as-built, okay, the last stage for this phase is as-built drawing. As-built drawings are the final documentation of what was actually constructed on site. They are prepared by the contractors and capture all the changes made during construction, whether due to site condition, design revisions, or coordination issue. These drawings are more than just a formality. They are a key part of project historical record and are essential for future maintenance, troubleshooting, or expansion of facility. For instance, if pipe is rerouted or a wall thickness is modified, it must be reflected in the as-built. Consultant typically review and approve as-built submission as part of the project closeout process. These drawings are handed over to client along with operation and maintenance manual, asset tags, and system certificates. In many cases, authorities may also require them for occupancy or compliance. As-built fall under RIBA stage 6, which is handover. They symbolize the completion of the physical work and formal documentation of the project. Here, we have finished all the design stages for the project lifecycle. With the technical design, you can see this, this according to RIBA, we are showing the 7 stages. But if you focus on the design phase, which we have completed until the handover, which is stage number 6. With the technical design complete, the project enters the build phase. Understanding the different phases of this life cycle ensure that drawings are developed and managed effectively throughout the project. Each stage, from the initial strategic definition to the final use stage, is critical for a successful construction projects. Now, let's have a look on the design economics. Design economics is a core competency in the RIGS framework and play a pivotal role in shaping projects from earlier stage. It's about integrating cost intelligence into the design process. But we are integrating the cost intelligence into the design process, not after the fact, but alongside the architect and engineer's creative decision. Professionals in this area help client and design team understand the financial impact of other choices. Whether it's opting for a modular system, selecting a facade treatment, or changing spatial layout, each decision can significantly affect the cost and long-term values. At every design milestone, concept, schematic, detailed cost advice must be provided to ensure that what's being proposed align with the budget and deliver optimum value. In practice, we prepare element cost plan, engage in value engineering session, and flag cost risk early. This results in better informed design that are affordable, practical, and sustainable. In terms of RIBA, this competency is most closely aligned with stage 2 to 4. BIM, Building Information Modeling, is a collaborative digital process that enables the creation, coordination, and management of intelligent 3D models across the entire project lifecycle, from concept to demolition. BIM, or Building Information Modeling, is a transformative approach to design and construction that brings intelligence and collaboration to the center of project delivery. Instead of working in isolated 2D drawings, BIM enables architects, engineers, and contractors to build and manage digital 3D models packed with information. These models evolve from simple meshing in early concept stages to highly detailed and coordinating construction-ready outputs. BIM is not just about geometry. It adds dimension like time in a BIM known as 4D, cost in a BIM known as 5D stage, the sustainability is a 6D, and eventually asset management, which is 7D. So the level of development, which is known as LOD, is a system used to define the progression of detail in a BIM model. For instance, LOD 200 models are still generic and used during schematic design, while LOD 300 includes coordinated geometric used in detailed design and tender stage. By LOD 400, models can be directly used for fabrication. Yes, let's have a look on the value engineering. Value engineering in the design plays a vital role in design development by ensuring that the project deliver maximum function at the best possible values. It's not about cutting cost randomly. It's about finding smarter alternatives that fulfill the same purpose. Value engineering should ideally start early during the concept and schematic stages. We already covered value engineering in schematic design stage as well. In schematic stage, when design changes are easier and less costly to implement. If we apply value engineering after schematic during detailed design, so we may have big impact in terms of delay and cost overrun. Okay. So let me share one example for value engineering. If the original design calls for expensive material or over-engineered system, the value engineer workshop can propose alternatives that are more economical but still meet the required performance and aesthetic goals. The value engineering involve collaboration between designer, cost consultant, engineers, and the client. It's structured process where we identify key functions, evaluate alternatives, and select solutions that offer better value. We have in this series, PIQS and cost umbrella series, we have dedicated webinar on this value engineering. So I don't remember exactly the number, but stay connected with us. So you will have more detail in that webinar. Sustainability and carbon emission. So is also we have to take care in the design. But first, let's define what we mean by sustainability in a construction. Sustainability refers to the responsible use of resources to meet our present needs without compromising the ability of future generation to meet theirs. This means that throughout a project, we strive to minimize waste and use resources efficiently, always keeping in mind that long-term impacts of our decisions. Okay, let's look at carbon emission. Carbon emission refers specifically to the release of carbon dioxide and other greenhouse gases into the atmosphere. In construction, this mostly comes from burning fossil fuel, which occurs during both the production of building materials and ongoing operation of the building. In construction, emissions are generally divided into two main categories. The number one is embodied carbon and number two is operation carbon. What is embodied carbon? Embodied carbon is generated during the production and transportation of materials like concrete and steel, as well as other construction activity. It includes all the carbon emitted before the building is even operational. The operation carbon. Operational carbon refer to the emission generated by energy used throughout the building's life. For example, for heating, cooling, and lighting. By understanding these categories, we can better strategize how to reduce total carbon emission over a building life cycle. To recognize and encourage sustainable building practices, several certifications are used globally, such as LEED, BREEAM, Passive House. These certifications help guide our design and construction strategies to be more sustainable and efficient. Sustainability is crucial throughout the design stages. It begins in strategic definition by setting ambitions like reduce emission and ecosystem impact. The brief stages sees these ambitions translated into a master plan with site analysis identifying passive design strategies and renewable energy options. Concept design then focus on eco-friendly materials and building orientation for minimal heat gain, while spatial coordination and technical design delve into energy efficient system and waste reduction. Energy modeling help ensure the project aligned with sustainable goals. With BIM, sustainability can be better integrated, all emphasizing the focusing on sustainability during design lead to efficient, comfortable, and valuable buildings. By applying sustainable design principle and pursuing recognized certification, not only benefit the planet, but can also enhance the value and performance of our building. Okay, so let's move on the critical phase in any construction project, which is a regulatory approval. This is where we ensure our design aligned with all application laws and standards. Regulatory approvals are essentially formal permission from government or municipal bodies. They confirm that our design meets legal, safety, zoning, environmental, and planning requirements. Think of them as our green light to proceed. Why is this so important? Let me explain few reasons. The first and foremost, it ensures we are operating within the bounds of the law, avoiding potential fines or legal issues down the road. Getting it right up front minimize the risk of costly delay or having to go back to the drawing board for redesign. Our design impact people's life. So regulatory approval is crucial for safeguard public health, safety, and overall well-being. And finally, it's essential for keeping the project moving smoothly and passing any necessary inspection from authorities. Let's look at a typically building permits process in the KSA. Every country has different regulations. So here we're going to cover only KSA. If you see on the screen, the stage 1, the first stage, we need to obtain a letter from the main municipality confirming the sustainability of the plot for our intended construction. This usually takes around 5 days. Stage 2, which is the next stage, we submit an application for preliminary location permit to the branch municipality, which also takes around 5 days. The stage 3, after the stage 2, we need to obtain fire department approval from civil defense for fire safety, fire and life safety, which typically takes around 10 days. The last stage, which is stage 4, finally, we apply for the final building permits from the branch municipality and submit it to main municipality for approval. Can take approximately 1 to 3 months. Keep in mind that the total duration of this whole process can vary, typically taking 3 to 4 months, depending on the project size and specific regional requirement. Okay, so here are the stage gate review. The stage gate process act like a quality filter for your projects. At each gate, the project team pause to evaluate whether the design is on the right track, meet performance and budget targets, and is ready to proceed to next phase. This method ensures that we don't carry unresolved issue forward, which can become costly during construction. For example, after the concept design, gate 2 is where the client sign off on the design intent and we benchmark our cost. If there is a misalignment here, it's much easier to correct now than later. Similarly, gate 4 ensure that detailed design is technically complete and ready for tender without ambiguity. So here is alignment with RIBA and PMI and ASCE. Let's briefly look at how international framework RIBA, ASCE, and PMI aligns across project stages. Each framework follows similar sequence. Early stages focus on defining the project. RIBA calls these strategic definition and preparation and brief. ASCE refers to ideation and planning, whereas PMI use feasibility and design. As the project develops, All framework address concept and schematic design, moving into detailed technical documentation. Construction phase terminology also align. In RIBA, we are saying construction. As per AAC, we are saying execution. As per PMI, it is known as execution or build. All frameworks emphasize the importance of shop drawing here. Finally, all end with a handover stage, whether it's called handover, RIBA. As per AAC, it's known as closure, or as per PMI, we can say it's a close stage. This including as-built documentation and preparation for facility management. In short, while the terminology differs, these frameworks cover the same main stages, helping us coordinating teams, clarify deliverables, and ensure smooth transition throughout the projects. So we have finished the project lifecycle for a design. So I just want to invite Mr. Akif, and I will just take 5 to 6 minutes break for a prayer, and he will continue. So stay connected. Mr. Akif, please.
Thank you so much, sir. First of all, I will request all of you, please mark your attendance through the link, which is already shared in the chat box. Those who will mark their attendance will get the certifications. So let me take a moment to introduce Cost Umbrella, the organization behind this webinar series. Cost Umbrella is a project management consultancy firm with its headquarters in UAE and regional offices in Saudi Arabia, USA, and Pakistan. We specialized in wide range of services, including project management, cost management and cost planning, quantity surveying, value engineering, life cycle costing, project controls and risk management. We are specialized in project performance audits, feasibility studies and financial modeling, valuation and advisory, and training and professional development. Our team has a proven track record of working on mega projects across various sectors, delivering exceptional results through our expertise and commitment to excellence. The more important thing, we are pleased to announce the upcoming launch of 2 specialized training program designed to enhance professional competency in the construction and consultancy industry. These courses are part of Cost Umbrella initiative to raise industry standards and build technical capacity across our professions, developed by industry experts and align with real world project demands. The curriculum emphasize practical applications, strategic thinking, and up-to-date industry methodologies. Each course will be recognized by internationally respected professional bodies, ensuring that participants gain not only advanced knowledge, but also globally respected credentials. So stay tuned as we prepare to open enrollment soon. Whether you are new or experienced, these programs will help you grow and succeed in today's competitive industry. So for more details about our services, projects, and about our team, please visit our website at www.costumumbrella.com. We are proud of our contribution to the industry and look forward to sharing our knowledge and experience with you through this webinar series. We have 5 minutes breaks, then our guest will join.
Yes, I'm back, and let's continue from where we left. So let me share the screen slides. Yes, I think we covered already the alignment with RIBA and PMI. Yes, okay. So here we have included in our today's presentation, we have included touch of procurement route only. It's not in detail. In our series, if you see that we have dedicated webinars on procurement routes, but here we will give you overview only. It will not be in detail, just overview. So as we move forward, let's briefly introduce the topic of procurement route in construction. Procurement is about selecting the best strategy to acquire the resources and services needed to deliver a project. The choice of route can significantly impact project risk, cost, and timeline. In today's session, we will just touch on a few common procurement routes, including their basic definition and approaches, such as traditional and design and build. We will only provide a high-level introduction here, as we have upcoming dedicated webinars where we will explore procurements in detail, as I explained you earlier, including specific route. In that series, in that webinar, we will include specific route and more insight. So let's have a brief. The procurement, according to RIGS, procurement refers to the entire process of obtaining goods and services from external sources, including deciding on the best strategy for the client's need and level of risk. The choice of procurement route, like traditional design and build, management contracting, construction management, or partnering, can significantly affect a project cost, risk, and schedule. Each route offers approaches for managing responsibility and risk between the client, designer, and contractor. Today, we will just provide this high-level overview to set the context. We won't go in detail on each route now, as we have a dedicated webinar coming up that will explore procurement strategies, their advantages, and where each is most effective. This introduction should help you understand why procurement decisions are so important as we move through project development. So let's have a look on the traditional procurement route, which is the most established approach in construction procurement. In this route, design and construction are kept separate. First, the client appoints a designer to prepare a complete design. Only after the design is finalized does the client contractor to carry out the construction. This means there are two distinct contracts, one for design and one for build. Some of the main advantages here are high design quality and control. As the client remains closely involved with the design process, you also get greater cost certainty before construction begins, and the process is widely understood in the industry. However, there are few shortcomings or disadvantages to consider this route. Since design and construction don't overlap, project can take longer. There's also less contractor involvement during the design phase, which can sometimes lead to disconnect between design and construction and less flexibility for making late changes. So let's briefly overview on the design and build procurement route. This is another common approach in the industry. In this route, the contractor takes on responsibility for both design and construction, usually based on the outline brief or performance specification provided by the clients. This approach offers a single point of responsibility, giving the client a simplified management structure and potentially less risk. Key feature includes early contractor involvement, which allow for practical inputs into design and can help drive efficiency. This route is especially suitable for fast-track projects since design and construction phases can overlap. Some key advantages are faster project delivery, reduced client risk due to single point of responsibility, and potential for cost and buildability improvement early in the process. However, the client has less control over the detailed design, and quality can sometimes be compromised if the lowest bidder wins. Also, managing variation can become costly. Remember, we are just providing an overview here. We will be covering design and build along with other procurement routes in much greater detail in a future dedicated webinars. So here we have now reached the question answer portion of our session. This is your opportunity to ask any question or share thoughts you may have about the topics we have discussed. And this presentation, hopefully within a couple of days, you will see on PIQS LinkedIn page. And you can give your feedback. And if you have any question, you can go to Cost Umbrella website, or you can refer on PIQS website or Cost LinkedIn page. So we will be happy to answer you. So please feel free to raise your question in chat box, or you can use our QR code if you prefer to submit your queries digitally or reach out after the session. We appreciate your engagement and look forward to addressing your question and feedback. Thank you.
Thank you so much, sir, for your time and such a great, insightful session. We have a question answer. So the first question, which stage we do pre-concept, stage 0 or 1? This question is from Srikesh. So I would like to ask Mr. Ismail to answer this.
Thank you. Can you hear me, Akib?
Yes, sir. Yes, sir.
Thank you. So if we align it with the RIBA project delivery plan, the pre-concept design is developed during RIBA stage 0, which is strategic definition. And the master plan is developed during the stage 1, which is preparation and brief. So answering the question of Mr. Sikesh, the pre-concept design is developed during RIBA stage 0.
Okay, sir. Next question. What if there is a potential change between IFT and IFC drawings? Will it lead to variations order? This question is from Mohammad Rafiq.
Okay.
Yeah, okay.
Yeah, Mr. Ismail.
Yes,
okay,
sir.
please.
Will you take it? Or you want me to take it?
Yeah, okay. So
Okay.
basically, in the IFC stage, it will lead to the variation order, but in IFT, it will not. Actually, if you see the slide, I have shown the slide, which was 4.1 and 2, and then we have shown the difference. So you will face the variation order once there is change in the IFC drawing, but in IFT, no, it's not. Thank you.
Yeah, I would also like to add something into it.
Yeah,
that,
please.
That if, let's say, there were some changes, those were recommended by the contractor during the bidding stage, and those changes have been already incorporated during the bidding stage before signing the contract, then it's not going to lead to the variation order. But let's say the IFT package was issued and the bid was submitted based on the IFT package. Later on, there were changes, okay, and for those changes, it will definitely lead to the variation order. Recently, we have gone through this. There are some mega 4 projects in Jeddah. So the drawings were issued. The client was in rush to issue the client even to issue the drawings. Even those drawings were not 100% completed. So bidders, they submitted their bid, and after that, once the execution was started, the drawing was changed. So then we did a very extensive exercise. First of all, we did the scope alignment. In the scope alignment, we highlighted the variance. What was the IFT drawings and what are the changes those have been incorporated? Because the contractor is basically giving you the feedback from constructability point of view. Sometimes the designer, once they are doing the design, okay, they are designing the project from design point of view, but maybe it's not practical on the side. But once the execution is started, the contractor is giving you the feedback. Then, based on his feedback, the design slightly changed. So, whatever the changes are being implemented after the signing of the contract, it will lead to the variation order. But the best practice is that if the IFT package was issued and the contractor had highlighted some points from the constructability point of view, better to incorporate these points during the bidding stage. Otherwise, it will lead to the variation orders and then to the disputes. Thank you.
Okay, we have a question from Saeed Ahmed. There is always miscoordination between VE for materials, systems, and required specification expecting by principal, architect, and client. How to outcome this problem? Sir Ismail, over to you.
Yes, the value engineering exercise is very important. What is the meaning of the value engineering? Improving the value. First of all, I want to let you know that we have a dedicated webinar on the value engineering, in which we will not only explore the value management and the value engineering, we will also let you know that what is the process of doing the value engineering. So value engineering is not only the reducing the cost. Value engineering is improving the value while keeping the project function, aesthetic, and look and feel same. So for instance, we have a project. We are going to construct a 4-star hotel. So during the schematic design, once the schematic design is finished, the best practice is to do the cost plan. Okay, the developer and the designer, they develop a cost plan aligned with NRM1, New Rule of Measurement 1. Okay, and the objective of this cost plan is to ensure that the project cost is within the budget. So once you conducted the cost plan 2, which is based on the schematic design, and let's say that the project value was more than your budget, then it will lead to the value engineering exercise. Now, in the value engineering exercise, you need to keep the project functionality, project look and feel, aesthetics as it is, and then you have to propose some potential ideas which can bring the project cost down. For example, for a 4-star hotel, if they are using the marble on the flooring, and you tell the client that instead of marble, you just use the ceramic tile, that is not a value engineering, because now you're going to change the project static. Okay, you're going to change the look and feel. Okay, maybe you will reduce the cost, but the project value, or let's say the project functionality, will not be same. Maybe it will be 2-star or 3-star hotel. But let's say if you say that there is a multi-story floor, okay, multi-story hotel building, and you change the slab from the solid slab to the post-tension slab. So that is a value engineering idea. So by using the slab from the solid slab to the post-tension slab, you are not going to reduce the project cost up to 15 to 20%. At the same time, you will reduce the project execution cycle, okay, for the concrete pouring. So in this way, you need to know what are the potential ideas which you have to raise to the designer and to the client. And once you agree the VE idea, then you need to change the design. So this is very, crucial that you implement, and you first of all you need to agree, and then you need to implement the value engineering ideas during the schematic design, because still you are on the schematic design. The design is completed 70%. Now you still have the opportunity to change the design. Okay, if there are some ideas those have been agreed between different stakeholders, you can implement these ideas during the detailed design before issuing the IFT package to the contractor. So we will deep dive in one of our webinars, in our webinar series on value engineering, and inshallah we'll give you more insights about it.
Okay, we have one more question. Where FEL is being used from Ahmed Gardezi? Sir Ismail, I would like you to please answer.
Yeah, the FEL is also a project delivery plan. Like we discussed, Mr. Tanviri has already discussed the other project delivery plan, like RIBA, plan of work, we have AAC, we have PMI. So likewise, FEL, front end loading, is another project delivery plan. But this project delivery plan is widely being used for oil and gas sector. So if we talk about Saudi Arabia, the Jazan refinery and Saudi Aramco, basically they are using this project delivery plan. And you know that, as we just explained, that there are 3 stages: FEL 1, FEL 2, FEL 3, business appraisal, project scope definition, and FEED. So in these first 3 stages, you do the feasibility, you do the project definition, and then you do the design, which is up to the schematic level. So that's why I'm sure that most of the people who are working here in Saudi Arabia, okay, they know that once we receive the bidding package from Saudi Aramco, it is not detailed design, it is not 100% design. The design is only up to schematic level. Then this is the design. This is the bidder's responsibility to do the design. So basically, it's a design and build procurement strategy, as we recently discussed. So FEL again is another project delivery plan, and this is being used widely in the oil and gas sector.
Thank you, sir. I think we are going to have one more question from Mohammed Nadeem. I would like to request Sir Tanvir, please answer it. How we know which method of project management is best suited?
Thank you, Mr. Dishan, for this question. Actually, each method have different unique characteristic. For example, if we refer to RIBA plan of work, it's most suitable for building and construction projects, architecture, and infrastructure projects. And if we go to the PMI, so PMI is software development, IT projects, where we have well-defined the scope. And if we refer to FEL, as we have explained in the presentation, that this one is for plant, oil and gas, chemical plants, large industrial projects. And in Saudi Arabia, Aramco is using this FEL method. So AAC is cost engineering, multi-phase projects, continuous focus. So I believe based on this parameter, we can adopt any method. Thank you.
Thank you so much, sir. The raised question will be entertained through email or you can scan the QR. We hope today's session offered useful insight and practical knowledge. A big thank you to our guest speaker, Mr. Tanvir Akhtar, for sharing his expertise and experience, and to all of you for active involvement. Thanks to all the attendees. The certificates for today's session will be distributed to all attendees through their registered email IDs. Our upcoming webinar will focus on bidding, techno-commercial. Please stay tuned for the remaining 9 webinars and keep visiting the LinkedIn pages of PIQS and Cost Umbrella for more information. Thank you once again, and we look forward to seeing you in the next session. Thank you so much.